So in 5a, to show that the equation 2x squared take 8x plus 13 equals 0 has no real roots, one way would be to try and use the quadratic formula on this equation and show that you're going to get the square root of a negative number within the formula, which of course you can't evaluate since you have no real roots. What is a much more efficient way is to realise that you just need to evaluate that part of the quadratic formula that is inside the square root symbol, and that's called the discriminant. So for your working, all you need to do is to say what the discriminant is going to be. Well, the discriminant is b squared minus 4ac, and that b is minus 8, so minus 8 times minus 8 squared, all squared is 64. Subtract 4, multiply by a is 2, and c is 13. So you're doing 64, subtract 4 times 2 times 13, so that's 64 take away 26, 104. Now, without actually having to work it out, because we don't need to work, we know 64 subtract 104 is negative. And that's the key thing. We need to show that when we work out b squared minus 4ac within the quadratic formula, we get a negative value. Hence, we've got no real roots. So to get your 3 marks, you need to have worked out b squared minus 4ac, worked it out correctly, and compared it with 0 to show that it's actually a negative number. Now, in part B, we're given the same terms, 2x squared minus 8x plus 13, but instead of having equals 0, we've got y equals 2x squared subtract 8x plus 13. So there's a relationship between A and B. A is looking at the particular case where 2x squared minus 8x plus 13 is 0, and B is looking at the more general case where 2x squared minus 8x plus 13 equals y. Now, when y equals 0 on the graph, then we're actually talking about points on the x-axis. So if we could solve 0 equals 2x squared minus 8x plus 13 and get some real numbers, and then we would know that the values for which 2x squared minus 8x plus 13 equals 0 give me the coordinates of the points on the x-axis. So the fact that I can't solve 2x squared minus 8x plus 13 equals 0 means that y is never equal to 0 on the graph. The graph is actually not going to cross the x-axis. And because it's a positive x squared term, you've got a graph like that. Because it doesn't actually cross the x-axis, you've got a situation like this. If this is your x-axis, it doesn't actually touch. So what does this result tell you about the graph? We know that it doesn't cross or touch or doesn't come in contact, or doesn't cross the x-axis. Now, in question 6, you're asked to describe the transformation that would map the graph of y equals x squared onto this graph that's shown on the page. Now, the graph of y equals x squared goes to the point 0, 0, 0, and in fact, it does something like this. 3, 9. Okay, so this is a graph of y equals x squared. I'm just showing the right-hand part of it, that it's symmetrical, just by putting a few numbers. So minus 2, 4, minus 3, 9. So you've got a graph a little bit like this, but less wobbly. Difficult to draw this correctly on the computer. All right. So you can see that this graph is slid. It's translated onto the red graph. So to describe a transformation fully for 2 marks, you need to have the first word for 1 mark. You need to say that it's a translation. Right, so that's a sliding movement. It's translation. And then you need to describe that translation in terms of a column vector. To go from the point 0, 0 to the point 5, 3, you're going right 5 and up 3, so using column vectors, right 5, the top number in the column vector is 5, and up 3, the bottom number in the column vector is 3. So it's a translation of column vector 5, 3. So 1 mark for translation, 1 mark for 5, 3. Now B says, state a possible equation for the curve. Now, what you're expected to know is that if you've got the graph of y equals x squared, if you want to move the graph of y equals x squared 5 units to the right, you replace the x in y equals x squared with x subtract 5. So you replace, if it's 5 to the right, you replace it with x minus 5. If it was 5 to the left, you replace x with x plus 5. So we've got y equals x minus 5 all squared. So y equals x minus 5 all squared just moves this graph 5 units to the right. Now to move it up 3, then you need to take the result and then add 3. So y equals x minus 5 all squared plus 3 has the effect of a translation of 5 units to the right and 3 units up. The question says give your answer in the form y equals ax squared plus bx plus c. So in other words, we need to multiply the bracket out before we finish. So it's x minus 5 all squared. Remembering it's x minus 5 multiplied x minus 5. So that's going to be x squared. Subtract 5x and then subtract another 5x. So let's subtract 10x. Minus 5 times minus 5 is plus 25. Plus 3. So that gives us y equals x squared subtract 10x plus 28. So we can see that it's in the correct form. A in this case is 1, B is minus 10, and C is 28.